I am Anil Kumar. Welcome to my YouTube channel. In this video, we'll consider 4 examples to solve trigonometric equations by factoring. We are working in the domain of 0 to 2 pi. Solve equations, provide exact solution, or round to the hundreds. You can use special triangles to find the exact solutions. Otherwise, use calculator to calculate the answers in radians. So the settings of the calculator should be in radians. Let's begin with the very first question, which is cos theta cosecant theta equals to 2 cosecant theta. Let's rewrite the equation. Cos theta cosecant theta equals to 2 cosecant theta. Now at this stage, please do not cancel cosecant theta since that will be a mistake, eliminating few solutions. We'll see it soon. Bring the terms together. So rewrite as cos theta cosecant theta minus 2 cosecant theta equals to 0. Now cosecant theta is common. You can factor cos theta minus 2 equals to 0. So now, using the properties of zero multiplication, we have two solutions here. We can write cosecant theta equals to 0, or we can say cos theta equals to 2. As you know, cos theta cannot be 2, so we have no solution for this one. Cosecant theta equals to 0 also does not have any solution, since you know that the value of cosecant theta is either less than minus 1 or greater than 1. So here also we have no solution. So in this particular example, we do not have any solution for the given equation. Now let us take up the second question, which is 4 sine theta tan theta plus 20 sine theta minus 3 tan theta equals to 15. You can bring the terms together and factor. Correct? In the first two terms, we have 4 sine theta as common. We are left with tan theta plus 4, 5, right? 20 divided by 4 is 5. Now we can take 3 common. We get tan theta plus 5 equals to 0. Now tan theta plus 5 is common, and that gives you 4 sine theta minus 3 equals to 0. So we have solution for tan theta equals to minus 5 or sine theta equals to 3 by 4. Within the domain of 0 to 2 pi, tan theta is minus 5 means you are in quadrant 1, you are in quadrant 2 or 3, right? So we have two solutions here. Minus means we are looking at the quadrant 2 and 4. For sine theta to be positive, we are looking at the quadrants 1 and 2. So we have 4 solutions within the domain of 0 to 2 pi. Now in each case, we should find the related acute angle alpha and then get the other solutions, right? So for tan theta equals to minus 5, I'll write down tan alpha equals to 5, right? So we'll find the related acute angle in quadrant 1. Setting the calculator in radians, we get shift tan, that gives us tan inverse of 5, and we get 1.373. So I'm going to round this as alpha equals to tan inverse of 5, which is 1.37. So what is going to be theta, which is between 0 to 2 pi? So the two solutions are, one is pi minus alpha, the other one is pi 2 pi minus alpha, correct? So theta equals to pi minus 1.37, and theta is also equal to 2 pi minus 1.37. Let's see what do we get. So we got pi minus 1.37, that gives us the value of 1.77, and then 2 pi, 2 times pi minus 1.37, and that gives us 4.91. So these are the two answers from the first factor, tan theta plus 5. Now let's find the other two answers from the second factor, which is sine theta is 3 by 4. Now 3 by 4 is positive. We can find angle alpha. So sine theta equals to 3 by 4. So alpha equals to sine inverse of 3 by 4, which is, let's use the calculator once again, shift sine inverse 3 by 4. And that gives us 0.848. I'm going to write this as 0.85. So alpha is 0.85. So the two angles for theta will be one in quadrant 1, which will be 0.85, and the other one will be pi minus 0.85, correct? Or is equal to, let's calculate, pi minus 0.85 gives us 2.29. 2.29. So that is how we get solution of this particular equation. So we have four answers. Theta is equal to 1.77, 4.91, 0.85, and 2.29. Make sense? So that is how we will be answering this particular question. Now let's move on and take up the next question, which is secant square x minus 2 tan square x equals to 0. Secant square x minus 2 tan square x equals to 0. Now 1 plus tan square x is secant square x. We can use that identity, right? So I'll replace secant square x as 1 plus tan square x minus 2 tan square x. So we're left with 1 minus tan square x equals to 0, or tan square x is equal to 1 means tan x equals to plus minus square root of 1, which is plus minus 1. So in this case, we have four different values, plus and minus 1. So the solutions will be pi by 4 is when tan is 1. So we have pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. So we get the value of x as equals to pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Perfect. So I hope you have understood the method of solving it. With that, we have solved 3 questions. I hope you have understood the strategy to solve these problems. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.